You're good.
Thank you, Laura. Excellent. My videographer, excellent, an extreme talent in terms of videography.
Thank you.
Okay,
Appreciate it.
excellent. She's failing physics, but she has an A in videography. Excellent, excellent. Now, did I say that out loud? I'm sorry, sometimes my filter something.
Your filter's not working today, Doris.
Your what?
2 points away from a 90. And after today, that's 50 points extra credit.
Okay.
I've been here all week.
Me too.
Every day.
You sound like an act in Vegas. Okay? She says, I've been here all week.
We have.
Okay.
4 o'clock.
This one is a little bit different. Remember I said that the volumetric expansion works for, you know, we're just going to do cubic centimeters? I lied. This problem is cubic meters. So you just have to make sure that you're using the correct beta. Correct? Easy? You got to make sure you're using the correct one. So this is the deal. I'll read the problem quickly. Just before midnight, when the air temperature is 10 degrees Celsius, which is cool, what is 10 times 1.8 plus 32? It's like 42, right? Is it 42?
50. Wait, 10 times 1.8 plus 32?
Yes.
50.
Oh, sorry, 50. So that's pretty cool. That's cool. Okay, so at night, when the temperature is 32 degrees, 10 degrees, Carl stops and fills the 0.06 cubic meter tank of his car. At noon the next day, when the temperature has risen to 32 degrees Celsius, Carl finds a puddle of gasoline beneath the car. What do you think happened? How much gasoline spilled out of Carl's car, assuming no change in volume of the tank? In other words, the tank isn't expanding. Okay. The beta for the gasoline is 3 times 10 to the negative 4th per degree Celsius. So if you're making a gasoline tank or making an engine where the engine's going to get hot and you need to cool it with a fluid, you want to choose a fluid that's going to have a very small expansion coefficient, wouldn't you say? Like water or antifreeze, right? Correct? So the gas in the tank, do you realize when you fill your tank up, the amount of gas on a hot day, it could read higher than normal because the gas is hot. Gas tanks, by and large, though, are insulated. They're well insulated. But it can still, you know, vary. So this is not a tremendously strange problem. Do you understand the problem? It's getting hot. The volume's going to expand. How much? So they want to know how much is it going to spill out? How much is it going to expand? Yeah? You with me? We're assuming that the tank is topped off completely, right to the brim. Yes? All right, so you just plug in. That's all you do. All right, we'll plug up here. So delta V equals the original volume, 0.06, times what? Let's move that over a little bit. So the delta V is going to be 0.06 times beta, which is 3 times 10 to the negative 4th, times, it goes from 10 to 32, which is what? 22. So delta V is going to be 0.06 times 22 times 3 times 10 to the negative 4th, and that equals 3 significant figures is fine.
3.96 times 10 to the negative 4th.
He said 3.96 times 10 to the negative 4th, what? Cubic meters, right?
Yes.
Excellent. He finished my sentence. Excellent. Good, good. So it's going to be 3.96 times 10 to the negative 4th cubic meters. And the answer to the first part of the problem is that the reason the gasoline is at the bottom of the tank, the first thing I would think of probably at that age, as a young person, would be, oh my God, there's a hole in my gas tank. Right? Not true. Yes?
If you're going from centi to meters, how many spaces are you moving?
Centi what?
Did you say from,
Centimeters,
yes, from
Cubic centimeters to cubic meters?
Yes, how many?
There are 1 million cubic centimeters in 1 cubic meter. But don't worry about it. We're not,
Okay.
don't worry about that information. That has nothing to do with this problem. I'm not going to give you, the question was, how do you convert from a beta that's for cubic centimeters to one that's for cubic meters? And the answer is, don't worry about it. If I give you it, and the volume is in cubic meters, the one I give you is, you have the right one. Okay? Enough said? Is that all right? Okay. Laura, excellent videographer.
Yeah, thanks.
We simply call her, we call her George Lucas. Georgina Lucas.
Okay.